Let's get started. Regroup. Alright, today we're tackling our last transformation, which is rotations. And then in addition, we'll spiral back in translations and reflections. So those of you that were gone last class, you'll get a little bit of review here. Alright, for the warm-up, first one, how many lines of reflectional symmetry does a regular hexagon have? Keyword regular. 6. Number 2, reflect triangle ABC over the y-axis. So hopefully you highlighted or something your y-axis. Okay, when you reflect over the y-axis, what changes? Your x value. So you're just flipping it across, and it looks something like so. Is it off the page? No? Cool. Oh, sorry, I meant to put this all on 5. Okay, well hopefully you drew it better than I did, because obviously I didn't do it right. Okay, and I shifted the whole thing over. Sweet. It's a great start. Okay, so more importantly though, what is your image and your pre-image? Pre-image is what you start with. Okay, and then your image is what you end with, and then make sure you have the proper notation with the tick marks. Okay, those tick marks show that it has been transformed. Okay, let's try this again. Number 3, the vertices of a triangle ABC are as it says. Translate the triangle 6 units to the left to form A prime, B prime, C prime. Write this transformation in coordinate notation. So what would it look like?
X minus 6y.
XY yields X minus 6y. So where would A prime be? Negative 1, 3. Where would B prime be? And C prime?
Negative 5.
Awesome. Okay, number 4. RST is being translated 5 units left and 3 units up. What would it be in coordinate notation? Okay, and where is R prime? S prime? And T prime. Very good. Questions on the review. So all of the translations and reflections, also symmetry. Cool. Okay. So rotations. Rotations are the trickiest one, which is why we put them on their own day, and it's only tricky because you have to memorize the rules. Okay, so there's 4 rules, essentially 3 rules that you'll memorize. Okay, when rotating, you always rotate in a counterclockwise direction unless told otherwise. Okay, so it is always counterclockwise. You might see CCW for counterclockwise. Okay, and it's always counterclockwise unless it specifically says the word clockwise in the problem. Okay, and it's always counterclockwise unless it specifically says. Questions on that? Okay. So one way to make a rotation about the origin is to use the quadrants in the coordinate plane. So it says to fill out the coordinate plane rules. Okay, if you were to rotate the point 64 counterclockwise. So I want you to plot the point 64. Okay, and this is point P. What quadrant is 64 in? 1. Okay, and what, when you talk about signs, positive and negative, what signs are in quadrant 1? Positive, positive. Okay, so your x is positive and your y is positive. Okay, and that's what brought us to the point 64. Okay, what is quadrant, or what's this quadrant? 2. What signs are in quadrant 2? Negative, positive. Okay, what about this one? What quadrant's this? 3. And what is our signs? Negative, negative. And then last but not least, you have 4. And what are the signs in 4? Okay. So, when you make a 90-degree rotation from wherever you're starting, okay, that's the hardest thing for people to differentiate, is that your starting location isn't always going to be in quadrant 1, okay? But a 90-degree rotation is always going to have the rule opposite y, x, okay? So a 90-degree rotation will always have the rule opposite y, x. And when I told you how to memorize rules, these are what I'm talking about. So you take your original point, which is xy, which is 6, 4. And now if I'm looking for a 90-degree rotation, where is point P going to be? Negative 4, 6. So plot point P. P prime. Okay? Now we're going to start back at P, okay? If we were to rotate another 90 degrees, so now we're 180 degrees from where we started, okay? Our rule is now negative x, negative y, or opposite x, opposite y. Okay? So what would our new point P be? Negative 6, negative 4. So it's still P prime because we're resorting back to original P every time. If I were to have rotated point P prime, that would be double prime. Okay, and what did I say? Negative 6, negative 4. And then if we rotate 90 degrees further, now we are at 270 degrees. Our rule is y negative x. Okay. So going back to point 6, 4, where would point P prime be? 4, negative 6. And plot that. Okay. I don't know if it will help you, but the way that I remember is this. Okay, I'm always going to start here, but just know that you're not always starting in quadrant 1. I just consider this my starting spot. Okay, your starting spot is always x, y, or whatever coordinate you are given. It could be negative 6, 3. Okay, but that's your original starting x, y. Okay, diagonal from that is 180 degrees, and it's still with x, y, but all you do is you take the opposite. Okay, but when they're diagonal from each other, so 0 and 180, it's going to have the order x, y. 90 degrees and 270 have the order y, x. Okay, 90 degrees comes first, right? Because when you're rotating, it goes 0, 90, 180, 270. So 90 degrees comes first, so you're going to make the very first coordinate opposite. Whereas 270 comes second, okay, in your order, not second in essence of after 90, okay? That means you are going to make x opposite. Like I said, it might not help you. That's how I remember it. But if you just want to memorize the rules, that's fine too. But just know that your 0 and 180 are in the order x, y, and then 180 degrees, you just flip it, or flip your signs. Okay, whereas 90 degrees and 270 degrees are in the order y, x. 90 degrees is first, so do the opposite y. 270 degrees comes after 90, so opposite x. If you like it, keep it, trash it, memorize it, whatever. Okay? So it could get a little bit more difficult in the sense that it could tell you clockwise. Okay? So counterclockwise versus clockwise. Okay, you have your 0 degrees, 90 degrees, 180, 270, and then you finish with 360. You're just going in 90-degree increments. Okay, what's our rule for 90 degrees counterclockwise? Negative y(x), 180 degrees.
Negative x, negative y.
270 degrees.
Y, negative x.
And 360 degrees. X, y, because you're back at the beginning. Okay, so those are all of our counterclockwise. That would also be just a great thing to write on the top of your test, just the table. Okay, if I'm at point P, okay, if I move 90 degrees clockwise, what rule does that match for counterclockwise? 270. If I move 180 degrees clockwise, where am I at? 180, so that stays the same. If I move 270 degrees clockwise, where am I at? 90, and then the rest stays the same. So the only difference between clockwise and counterclockwise, it's just the opposite rule. Okay, so 0 still goes with 360, 180 still goes with 180. The only ones that swap are your 90 and 270. So 90 degrees counterclockwise has the same rule as 270 degrees clockwise. And 270 degrees counterclockwise has the same rule as 90 degrees clockwise. Yes.
So,
Oh, did I make a mistake? That's 270.
I was so confused.
Sorry. Questions? Okay, I want you to take like 2 minutes and with the people at your table or the person next to you, just kind of quiz each other on the rules. Okay, take a couple of minutes and just quiz each other on the rules. Quiz them counterclockwise and clockwise.
Okay, go. Okay. Okay, turn your paper over so your rules aren't facing up. Alright, I need to turn mine too. Okay, what is the rule for 90 degrees clockwise? Y negative X. Okay?
Clockwise. What is the rule for 180 degrees counterclockwise? Okay, what is the rule for 360 degrees? What is the rule for 90 degrees? How did you know? Very good. I did that on purpose. It is always counterclockwise unless I say, or the paper says, whatever, clockwise. Very good. 270 degrees counterclockwise. Okay, 0 degrees. 180 degrees clockwise. Okay, questions? Okay, one other thing of practice. Okay, my point C for Cologne is at negative 2, 5. Negative 2, 5. Okay, what happens when I rotate 90 degrees? So what's my rule first? Okay, so then what is my point? -5, -2. Okay, what about 180 degrees clockwise? What's my rule? Okay, so what is my new point? Okay, are we picking up now? Okay, so the reason why I wanted to give you this point was you're not always starting literally in quadrant 1. Okay, but all of your rotations are based off of just 90-degree rotations, no matter where you start. Okay, so it's 90 plus 90 is 180 plus 90, 270, etc. But you can start anywhere. Okay, however, you do need to know the order of the quadrants. 1, 2, 3, 4, because you could have a test question that says after this transformation and this transformation happens, which quadrant is your figure in? And so that's why I wanted to go over the coordinate plane. Okay, and make sure you know that it is labeled counterclockwise. 1, 2, 3, 4. Got it? Okay, go back to your notes. Okay, number 1. Rotate ABC 90 degrees about the origin. What's our rule for 90 degrees? Negative YX, which direction? Counterclockwise. Okay, so where is A currently? 4, 0. Where's B currently? 3, 4. And C? Okay, so applying my rule opposite YX, where's A prime? 0, 4. B prime? And C prime? Sweet. Questions on that? Okay, what about rotating just the point, 3, 4, 180 degrees about the origin? Which direction? Counterclockwise. What's our rule? And so what's our B prime at? Sweetness.
This isn't too bad.
It's just memorizing the rules. Questions on that? Okay. Number 3. Rotate ABC, whose coordinates are at A, 3, 3, B, 3, 4, C, 6, 2, 90 degrees about the origin. So which direction? Counterclockwise. What's the rule? Oops. Counterclockwise is supposed to go here. Okay, so if A is currently at 3, 3, where would A prime be? B prime? And C prime? That's it. The reason the graph is here is so, like, if you plotted your original point, and you wanted to turn your paper and, like, use that quadrant rules, you could just keep turning it so that you knew. But I think if you just memorize the rules, it's way easier. Okay, so now we are looking at composition of transformations. A composition of transformations just means more than one is being applied. Okay, so maybe a rotation or a reflection or a translation and rotation or whatever. Okay, plot the points A16, B38, C210 to form triangle ABC. So since it says to plot, go ahead and do that. Okay, our first transformation is 90 degrees counterclockwise. What is the rule associated with that? Negative yx. Okay, so if we take all of our points and do negative yx, where's A prime? Negative 6, 1. B prime? And C prime? Okay, so plot those points. Okay, and then we're translating down 3 units. What does that look like in coordinate notation? Oops, x, y. Yield x, y minus 3. Okay, because it wants you to do both transformations, okay, to the same point, okay, now you're looking at the 90 degrees as your x, y, and then you're moving these coordinates down 3. Okay, so if I move A prime down 3, where am I at? If I'm moving B prime down 3, not 1, 0, because you're going down 3. And then C double prime is going to be where? Very good. And this time we're going to use 2 tick marks because it was the second transformation that has been applied. Okay, so you don't have to use a table, I just recommend it, because the more you try to do them in your head, the bigger of a chance you'll make a mistake. Okay, so just kind of get into the habit of making a little table. Questions? Okay. Okay, number 2. Use triangle JGF to do the following transformations. First, it wants you to reflect over the line x equals 6, and then B wants you to translate up 5 units. Okay, so draw your line x equals 6. Okay, how many, so we're currently at 4, so how far are we away from 6? 2, okay, so you can either count or do the algebra, okay, but where's your new point going to be? 8, 6. Okay, J is how far away? 4, so we need to move them 4 away from the other side. So where's J prime? Am I messing up? No. They just have F, Y. Oh, okay. I was like, what happened? Okay. So G, this should be.
The bottom F should be.
Okay, that's where I was like, okay. So J should be where? 10, 4?
Yeah.
Okay. Okay, and G is currently at 2, 8, and where is G prime gonna be?
10, 8.
Cool. Okay, so I have G prime, F prime, and J prime. Okay, and then it wants you to translate up 5 units. Okay, so this was reflect over x equals 6. This is translate up 5. So where is F double prime? 8, 11. G double prime. And J double prime. And you can just move those all up. Questions on the composition so far? Okay. Number 3 wants you to reflect over the x-axis and then rotate 90 degrees. Okay, so reflect over x and rotate 90 degrees. Okay, what's our coordinate notation when we reflect over x? What's changing when you reflect over x? Y, so there you go, x opposite y. Okay, and then what's our 90-degree rotation rule? Negative y. Or yes, xy yields negative yx. Okay, so our point is currently at 3, negative 2. Okay, after I reflect over the x-axis, what's going to happen? P is going to be where? 3, 2. Okay, and now if I rotate 3, 2, 90 degrees, now what? Negative 2, 3. Questions on that? Okay, number 4. Rotate triangle DEF 270 degrees clockwise about the origin. What will the coordinates of the midpoint of segment D prime E prime, the image of segment DE? So what would be the midpoint? So 270 degrees clockwise has which rule? Very good. Clockwise. So you're doing the 90-degree counterclockwise rule. So where would D prime be? You're currently at negative 2, 2. Negative 2, negative 2. Where would E prime be? And F prime? Awesome. So how do I find the midpoint? Anybody remember? Yep. It's a formula, but... Very good. x1 plus x2 over 2. You add your x's, divide by 2. Add your y's and divide by 2. It's like taking the average. Okay, so finding it of DE, I have negative 2 plus a negative 5 over 2. Negative 2 plus 1 over 2. What's negative 2 plus a negative 5? Negative 7 over 2. And I have negative 2 plus 1 over 2, which is going to be what? Negative 2 plus 1 is? Negative 1 over 2. So a little throwback to midpoint. Questions on that one? Cool. Okay, last three. Are you good? Okay. These were supposed to be little yield signs, the little arrows, and these little rectangles. Okay. Kinsey performed the following pair of transformations on point M to get M prime and then M double prime. Okay, so which transformations did she perform? So when you're looking at 3, 2, this is your X and your Y. Okay, then her new M prime point is at -2, 3. What happened to her ordered pair? -YX. Okay, and then from -YX, we went from -2 to 6. -2, 6. Okay, so what happened now? Translated what? Up 3. Okay. So, your original -2, 3, which you told me the rule was -YX, what happened there? 90 degrees counterclockwise or 270 clockwise and then up 3. So, which answer choice best matches what happened? C. You 100,000% will have one like that on your quiz and on your test. And maybe a skills check.
So we go in order like what happened, right?
Yeah, you go order by the tick mark. Questions on that? Okay. If you were to have graphed it, if you started at 3, 2, and then went to -2, 3, well, you rotated into the next quadrant, so that should tell you that you did a 90-degree rotation as well. Okay, and then check your rule to make sure it was true, and it wasn't just like translated or something. Okay, number 6. Point P, which is at 3, 1, is rotated 90 degrees clockwise. Okay, what rule is that? Y negative X, because it is clockwise. Okay, so where would P prime be? 1, -3. Okay, it wants to know a different coordinate rule that could also describe this transformation. How else could I get to 1, -3? 270 degrees counterclockwise. Okay, how else could I have got there? Translation what? Down 4 and left 2. Okay, I tell you now, on your test, quiz, near future, it's probably going to want the translation. Just saying the opposite rotation is a little too easy. So make sure you can identify the translation that happens too. Questions on that? Okay, 7. -3, -2 is rotated 180 degrees. What's the coordinate rule that could also describe it? Okay, so what is the rule for 180 degrees? -X, -Y, so where would K prime be? 3, 2. You're swapping your Y's and your X. Okay, so we're at 3, 2. What's another way that we could get there? 180 degrees clockwise, but what else? Translation how? Make sure you write it in the right order. Left and right goes first with your x coordinate, up and down goes second with your y. Okay? Question. How do we feel? Okay, close it and let's see if you can recite the rules as I say them. So just turn it over. Okay, here we go. 0 degrees. X, Y. 90 degrees. Negative y, x. 90 degrees counterclockwise.
Negative
y, x. I got you already on the third one. Okay, 180 degrees counterclockwise. Negative x, negative y. 270 degrees clockwise. Negative y, x. 360 degrees. X, y. 270 degrees counterclockwise. Y, negative x. 90 degrees clockwise. Y, negative x. 180 degrees counterclockwise. Negative x, negative y. There are some of you that aren't participating whatsoever, and I'm hoping it's because you know it. Okay? I'm watching you, just so you know. Okay, 90 degrees clockwise. I, negative x. Okay. Questions? No? Let's see. We could probably